All right, so everyone, welcome to college algebra, algebra and trigonometry, math 111, chapter 1, equations, where we'll be talking about equations and inequalities. And under section 1.1, we will be discussing graphs and graphing utilities. So the objectives are by the end of this lesson, we should be able to plot some points on a coordinate system. We should be able to graph equations in a rectangular coordinate system. We should be able to interpret about the graphing utilities viewing rectangular table. We should be also be able to use a graph to determine what are the intercepts and interpret information given on graphs. All right. So when we talk about the rectangular coordinate system, we mean a coordinate system where we have an x-axis, which is represented by a horizontal line, and a y-axis, which is also represented by a vertical line. And at the center of the y-axis and the x-axis is known as the origin, which is the point 0. It's known as the point. The point 0 is known as the origin. On the left of the point 0, you have the negative axis, and on the right on the horizontal left of the origin, you have the negative axis, and on the right of on the horizontal right of the 0 point of origin, you have the positive axis, and at the top of the horizontal line, you also have the positive y-axis, and and below the horizontal line or the x-axis, you also have the negative y-axis. All right, so the rectangular coordinate system basically has it divides a rectangle into 4 zones. And as you can see here from this diagram, the first box to the top right, that is positive. That's the positive axis. So that is the box where you have both the x-axis and the y-axis being positive. And in the second box to the left of that, you have the y-axis being positive and the x-axis being negative. And the third box, you have all negative. You have both x-axis and y-axis being negative. And in the last box, you have the x-axis being positive and the y-axis being negative. So we call each pair of points in the rectangular coordinate system an ordered pair. So for any point on a graph, we have the x component and we have the y component, and together we call them the ordered. We call them the ordered pair. We have the x coordinates, which is the x-axis value, and the y coordinate, which is the y-axis value, and together we call those two pair of points an ordered pair. So for example, we can begin by plotting the points -2. So let me share my blackboard, and -2. For example, look at how to plot the points -2 and 4. So for example, we are to plot the points, the ordered pair -2 and 4. We have to plot this point in the rectangular coordinate system. So what we do, we should draw a rectangular coordinate system. This is the y-axis. And we draw a horizontal line, which is the x-axis. And next we put some points on the on the x-axis on the y-axis. So for x-axis, we can choose numbers like 1 to 5. And the point of origin is 0 here. So 1, 2, 3, 4, 5. And on the y-axis, 2, 1, 2, 3, 4, and 5. And this is -1, -2, -3, -4, and -5. And on the x-axis here to the left, you have -1, -2, -3, -4, and -5. Okay, so the pair of points, -2 and 4, we trace 2 on the x-axis and 4 on the y-axis. So you see that the point of intersection of -2 on the x-axis and 4 on the y-axis is this point. So this is how we plot the points, -2 and 4. We can plot other points too. Let's say we want to plot the points 3 and 4. So that means the x coordinate is 3, the y coordinate is 4. So x coordinate 3 and y coordinate 4. And you can see that the point of intersection of 3 and 4 is here. So this is how we plot 3 and 4. And this point here is -2 and 4. So we can plot points on the rectangular coordinate system as such. We draw our x-axis, y-axis, we label it with points. Then we try to trace the x-axis and the y-axis points, and we join them with a dot. So that's how we plot a pair of other pairs in the rectangular coordinate system. Right, let me move back to the slide. All right. So for example, to plot a pair of points 4 and -2, we move the x-axis point is 4, positive 4. So we move 4 points on the right, and we move 2 points below to trace the point 4 and -2. So to trace the point 4 and -2, we move 4 units to the right or in the positive x-axis, and 2 units down, just 2 units down the negative y-axis. All right, so we can also be, so there are also graphs also describe the relationship between quantities. We can use graphs to describe the relationship between quantities, such as the relationship between age and height, the relationship between the amount of time that a person studies and their grade on a test, etc. We can always use graphs to represent certain relationships. And we said the solution of an equation in 2 variables. An equation in 2 variables means we have 2 variables in the equation. For example, the equation that we see, y is equal to 4 minus x squared. X is a variable, y is a variable. So this is an equation in 2 variables. When we have a value for the x, we can substitute into this equation to find the value for the y. So when we substitute the value for x into the equation to obtain the value for the y, we say we can obtain a true statement. For example, first of all, we want to graph this equation. y is equal to x plus 1. And we're going to select values from -4, ending with +2. But generally, if you have any equation and you like to graph, you can select points from x values from -5 to +5, and you can find the corresponding y values. Then afterwards, you try to plot those points on the graph, then you join them. So let us try to graph this. Y is equal to absolute value of x plus 1. We call these bars around the x plus 1 the absolute value. It means we only take the positive part after we evaluate the equation. For every x value that we substitute into this equation, the final result, we only take the positive part. That is what the absolute value means. All right, so let's share my, let me share my blackboard, and let's try to solve this. All right, so we have our equation is y is equal to the absolute value of x plus 1. All right, so let's pick points, x points from -5 to +5. Then we find the corresponding y values. So we have the x. Let's draw a table. And we have y, which is equal to the absolute value of y, which is, let's first find x plus 1. And we find the absolute value in the third table. All right, so x value is -5 to +5. So -4, -3, -2, -1. We have 0, 1, 2, 3, 4, and 5. All right, so if x is equal to -5, then we have y is equal to x plus 1, right? So if x is -5, so we have -5 plus 1, which is equal to -4. And the absolute value of -4 is equal to 4. If x is equal to -4, we have -4 plus 1, which is -3. And the absolute value of -3 is +3. If x is equal to -3, we have -3 plus 1, which is equal to -2. The absolute value of -2 is equal to 2. And if x is equal to -2 plus 1, this -1, absolute value of -1 is equal to +1. And -1 plus 1 is equal to 0. Absolute value of 0 is equal to 0. If x is 0, we have 0 plus 1, which is 1. And absolute value of 1 is still 1. And 1 plus 1 is equal to 2. Absolute value of 2 is equal to 2. 1 plus 2 is equal to 3. Absolute value of 3 is equal to 3. 1 plus 3 equals to 4. Absolute value of 4 is 4. 1 plus 4 is equal to 5. Absolute value of 5 is equal to 5. And 1 plus 5 is equal to 6. Absolute value of 6 is equal to 6. All right, so we have these pair of points. We have these pair of points. We have the x values here, and we have the corresponding y values here. So these are the x coordinates, and these are the y coordinates. So this will be the x coordinates, and this will be the y coordinates. So we can plot these pair of points on the number line as trying to do. Let me try to straighten out my line. So I have my y-axis here, and I have my x-axis here. So this is my y-axis, and this is my y-axis again, and this is my x-axis. All right, so let's try to put these points on the number line. So this is the origin of 1, 2, 3, 4, 5. This is -1, -2, -3, -4, -5, and here 1, 2, 3, 4, and 5. And down here you have the -1, -2, -3, -4, and -5. All right, so let's try to plot our pair of points. So when x is -5, we move 5 units to the left, -5, and we move 4 units up. So -5 and 4 is about, it's about here. So this is -4, -5 and 4. The next pair of points is x is -4, y is +3. So we go here. This is x is -4, y is +3. And the next one is x is -3, y is +2. And the next one, x is -2, y is +1. And the next one is x is -1, x is -1, and y is 0. So that would be this point. X is -1, y is 0 is on this point. X is -1, the y value is 0, means you're on the x-axis. The next one is x is +1 and y is 2. X is +1 and y is 2 is about here. The next one, x is +2 and y is +3. So +2 and y is +3 will be about this point. The next one, x is 3 and y is 4. X is 3, y is 4. Will be this point. The next one, x is 4, y is 5. X is 4, y is 5. It's about this point. let me add a 6 here, since the last is a 6. The last one is x is 5, y is 6. It'd be about this point. Let me redraw this point again. X is 5, y is 6 is about this point. So we can draw a straight line through these points as such. So this is the graph of y is equal to absolute value of x plus 1. All right, so this is how we graph. This is how we graph an equation. We select values of x from -5 to +5, and we substitute those values into y. Then once we substitute those values into y, then we have an ordered pair of x and y points. Then afterwards, we try to trace these points on the graph. All right, so let me go back to the slides. All right, so graphing utilities, when we talk about graphing utilities, we mean software packages for computers that allow us to plot graphs. So the TI-883 has a graphing utility that can be used to plot graphs. And there are several computing software that have functions that allow us to plot graphs. So graphing utilities basically mean plotting graphs. And then any standard graphing utility, the standard settings, the x-axis should range from -10 to +10. The y-axis should also range from -10 to +10. Those are the standard viewing rectangles. All right, so if you have a TI calculator, we can before we plot any graphs, you have to make sure the settings are within the standard range from -10 to 10. So if they are not, you can specify by going to the window function of the TI-883 and doing this. So when we talk about the intercept of a graph, we mean the point at which the graph intercepts the x-axis or the y-axis. So when we talk about the y-intercept, the y-intercept means the point on the graph where on the graph where it cuts or it meets or intersects the y-axis. And when we talk about the x-intercept, we mean the point where the graph intersects with the x-axis. At the x-intercept, the y value is 0. And at the y-intercept, the x value is also 0. So let me quickly show you how what the x-intercept and y-intercept is on the graph. Let me go back to my blackboard. Yeah, so let me go to my blackboard. Let me stop sharing and share again. Okay, let me share again. All right, so suppose you have any graph like this. Let's say you have a graph like y is equal to, have an equation like y is equal to x squared. This will look something like this. When we talk about the y-intercept, okay, this is not a good graph. Let me draw something else. Let me, let me draw Let me draw something else, different graph to explain this. Let's say we have this graph, y is equal to x squared minus 1. It will look something like this. Let's say we have a graph like this, y is equal to x squared. On the number line, it's going to look something like this. So we can actually draw this by picking x values from -5, -5 to +5. And once we have these x values, we can find the corresponding y values, which is equal to x squared minus 1. So we can actually plot this, but to explain the concept of intercept, the x-intercept is where the graph intersects with the x-axis. So you can see that for this graph, it has two intercepts. It meets the x-axis at two places. So this is an x-intercept. And this also, so -1, +1, and then also an x-intercept. And this point here, this is the y-intercept. So at the point where it intersects with the x-axis, this point here, the other pair here, the x value is -1 and the y value is 0. And at this point here, where it intersects the x-axis, the other pair here, x value is 1 and the y value is 0. And at this point here, where it intersects the y-axis, the other pair, the x value is 0 and the y value is -1. So you can see that at the intercept, if it's an x-intercept, the y value is 0 and the x value is the number on the x-axis at which the graph intersects the x-axis. And on the other hand, for the y-intercept, the x value is 0 and the y-intercept is the number on the y-axis for which the graph intersects the y-axis. Let me go back to the slides again. So that is how we describe intercepts, the x-intercept and the y-intercept. Where the graph meets or intersects with the x-axis, x-intercept, where intersects with the y-axis is the y-intercept. So you can see here, the x-intercept is the point -3, and the y value component is 0. And you can see that the 0.6 is the y-intercept and the x value is actually 5. The 0.5 is the y-intercept and the x value is 0. So you have 0, 5, which is the y-intercept, and -3 and 0, which is the x-intercept. All right, so we can be given an equation and in two variables, and one of the variables in the equation can be given, and we can be asked to find the other one. So for example, for this example, we have divorce rates are considerably higher for those who marry younger, but education may also play a role in the longevity of a marriage. And the equation D is equal to 1.8n plus 14 models the percentage D of marriages that end in divorce after n years when married with a high school but no college education. Determine the percentage of marriages ending in divorce after 15 years of high school graduates with no degree. All right. So D is the percentage. So from this equation, we are told that D is the percent of marriages that end in divorce. And N is the number of years married with a high school but no college education. So if we are given an N value of equal to 15, to find the divorce rate, you would have to substitute 15 in place of N into this equation to find the divorce rate. So let us try and do that. So let me share my Blackboard again. So we are told that the percent of divorce rate is equal to 1.8 n plus, let me go back again and pick the value. 1.8 plus 14. 1.8 plus 14. Where these divorce rates, divorce percent, and then there's a number of high school education. All right, so we are given n is equal to 15. So the divorce percentage is equal to 1.8 times 15 plus 14. And so we can work this out by multiplying 1.8 by 15. And once we multiply 1.8 by 15, we can, once we multiply 1.8 by 15, we can then add the result of that to, we can add the result of that to 14 to find the divorce rate. So 1.8 times 15 is, so you can use your calculator if you can do this. 1.8 times 15 is 27. So 1.8 times 15 is 27. So this is 27. And we add 14. So 1.8 times 15 is 27 plus 14. So this gives us 41. 27 plus 14 gives us 41. So D is equal to 41%. So the percent of divorce rates given the 10 years, given 15 years of high school education is 41%. All right, so let's go back to our slides. Okay. All right. All right, so this brings us to the end of section 1.1. And if you have any questions, you can send me an email. All right, just see you on the next one.